6.1.2c. A function f of x satisfies the following conditions. F is concave down for x less than 1. F is concave up for x greater than 1. And f prime of 1 is not 0. Okay, so let's start with the first two statements. F is concave down on the left side, so when x is less than 1, we want it to be kind of cupped downward. Notice it doesn't say anything about whether it's increasing or decreasing, just the concavity. So in graph A, I see this is actually concave up on the left side, and then it's concave down on the right side. So it is not graph A. Graph B is concave up on the left side, and then concave down on the right side, so it's not graph B. Graph C is concave down initially, and then it switches to concave up. So C is in the running based on those first two statements. And D is concave down when x is less than 1, because here's x equals 1, and then it's concave up after. Alright, so it's either graph C or graph D. Now to determine which, we need to look at that third statement. It says f prime of 1 is not 0. Okay, so f prime of 1 would mean the slope of the tangent line at x equals 1. So if it equals 0, that means it should flatten out. There should be like a way that I could draw a tangent line at x equals 1, like in graph C. If I drew the tangent line at x equals 1, it would be a horizontal line with a slope of 0. But statement 3 didn't say that it equals 0, it said it's not 0. And so that's what eliminates choice C. In choice D, if you try to draw a tangent line at x equals 1, it will have a negative slope because the graph is decreasing right there. And certainly it would have a slope that is not 0, it's some negative number. And so the only one of these that could represent f of x is choice D.